Hi there, my name is Mark Loinez. I'm the Vice President of R&D for the 30s team in Cadence Silicon Solutions Group.
Hi, I'm John Smith, Sales Director for North America for Teledyne LeCroy. And we're here to talk to you today about our Gen 6 CrossSync PHY test solution.
Okay, we have it hooked up to the Cadence PCIe subsystem demo, where we have one of our test chips acting as endpoint and one of our test chips acting as root port, connected through a backplane, and then with the interposer from LeCroy sitting in between. And so just to talk about the Cadence test chips, this is our 3nm test chip. It's got by 8 PCIe 6.0 on both sides, and they're talking to each other, and they've linked up in by 8. And you can see on the screen later that we have 8 links that are up. What we're going to do here, we're going to showcase the amazing debug capabilities of the LeCroy CrossSync system. And what we're going to do is we're going to zoom in on the exact point where we transition from NRZ and PCIe Gen 5 to PAM4 and PCIe Gen 6. Okay, and John, can you take us through it?
Good, I'll go through here. So what I'm showing on the screen up here, on the left-hand side is the scope trace. The top yellow trace is the upstream data and the zoomed-in portion of the upstream data. On the right-hand side is the protocol trace. So both the protocol and the electrical are captured at the same time.
So we went to EQ phase 0 and then looked with the protocol analyzer and got to the exact point where we have the TS0 to TS1 transition. And that is important because...
That's right, exactly, because that allows you to see exactly when the PAM2 to PAM4 transition happens. And we're showing that. So we use the analyzer to set that trigger capability up. So the analyzer is set up to recognize a speed change from 32 gig to 64 gig. Then it looks for a TS0 followed by a TS1. That's the state at which the link is going to change from a 32 gig to 64 gig, PAM2 to PAM4.
Yeah, so you can see that. You can kind of see here, if you look closely, there's 2 levels in this signal. And then if you look closely here, there's 4 levels of that signal. And then we can zoom in and actually see how the characteristics of the waveform look at even higher resolution.
Yeah. So if we zoom in on that portion, now we can see more of the wave shape.
This thing is sampling at 300 gigasamples per second, right?
320 gigasamples, correct.
Okay.
So now you can see the wave shape.
Yeah, this is NRZ, and then you can see the characteristic of the waveform just change, and that's PAM4.
That's right.
Amazing.
That's exactly right.
Tremendous resolution.
Now, when we say NRZ, technically it's actually PAM4, but it's the low frequency portion, so 0303 transitions over to the 4 transitions. And if you want to, you can then make timing relationships. You place cursors on screen, make timing relationships. And one more thing, the synchronization between the electrical, the scope, and the protocol analyzer are time aligned. So you have basically 2 data sets. You've got the acquisition from the scope and the buffer trace from the analyzer. Both are time aligned and displayed to the end user so you can do some serious debug.
Yeah, so if you had a problem with the CDR wandering off right at the transition, you could actually get the waveform, really understand what's going on, and even simulate it in your system set. Thank you for your time. For more information, go to cadence.com.
Thanks again for your time. For more information on this test solution, the CrossSync PHY Gen 6, and all of the Teledyne solutions, visit TeledyneLeCroy.com.